All right, we're going to do a one sample t-test. I'm going to go through everything with you here, each of the steps to finish a t-test up. And I've given you kind of a no-brainer set of data, so you can almost look at the data and tell that the alternate is probably true. But here we go. So the species diversity of freshwater ponds was recently studied by counting the number of species located in the ponds across Nebraska. They're all freshwater. It was found that the mean number of species in each of these ponds is about 11. There are also thousands of ponds in Nebraska that are considered high saline. A researcher assumes that ponds considered high saline, above 2, and I would say milligrams of sodium per centimeter squared, something like that, have lower diversity. To test this assumption, this researcher randomly chooses 11 of these ponds and counts the number of species living in them. The data is as follows. So he went through, found 11 ponds randomly, and counted the number of species located in them. So 6, 5, 6, 8, 8, 8, 5, 2, 3, 3, 3, 2, 2. What can we say about the assumption, or about his assumption? So the first thing you want to do is state the null and alternative hypothesis. So my null hypothesis is that the mean is 11. My alternate hypothesis is that his assumption is that mean is less than 11 in these saline ponds. And mu is the number of species, and you could probably add that in saline ponds in Nebraska, if you wanted to be more specific. All right, we'll check our conditions. Random, yeah, the researcher randomly selected the 11 ponds in Nebraska. Independent, so the 11 ponds is less than 10% of all ponds in Nebraska. And then we'll switch over to large counts. Now for large counts, we're going to have to graph this because we've got less than 30 in our sample, so we can't assume normality. And so we have to count this, graph this to see what it is. So what I've got here is we're going to do it in two ways. We're going to do it with GeoGebra. So just really quickly, I went ahead and hit started GeoGebra, and I entered the data as a spreadsheet, and here's the data. So I'll go ahead and do a one variable analysis of that data, and maybe I better, I didn't have it highlighted. We'll hit that again. There it is. And we immediately have a problem here. We need to we're looking for no outliers and only slight skewness. This looks pretty strongly skewed right. So we probably have an issue. We're going to continue anyway, and we'll look at all three just to show you all three. So you'd want to rough sketch that and explain that this is probably skewed too much to continue with the t-test, but this one is also, the box plot really shows a skewed right. But what's kind of neat is the normal quintile plot roughly follows a straight line, so we'll like I say, we'll continue anyway, but you want to put those in to show, typically, the data you have is kind of scrubbed and pristine for most of academic stuff in terms of teaching this to kids, but this is what could happen, and we have some issues that we'd have to deal with. So how I would state that is I would draw the graphs, say it looks like we have a pretty strong skew right, but we're going to continue with the t-test anyway. And also to show you on the TI Inspire, because you can't use GeoGebra on the AP test, we can go ahead and I went ahead and entered it. So I did I went to the home screen, did a spreadsheet, and then I typed in the data. You can see all 11 in there. And then I named it species up here, just typed in species. And so if we wanted to check our conditions for our large counts in this one, we would do a control doc, and we're going to add a data and statistic. And I'm going to click add variable and species. And there you can see just in the dot plot that that is skewed right, just like in GeoGebra. I'm going to hit menu and change my plot type to a box plot so we can take a look at it, and you can see the same skewness there. And we're going to change the plot type to histogram. There it is. You can see that same skew right. And whoops, excuse me, we'll do change it one more time, so menu, plot type, and we'll do the normal probability plot or normal quintile, and you can kind of see that it does, we've got some skewness there obviously, but it does fairly follow the line okay. But like I say, that shows you how to put it in an Inspire. So now we'll continue on with the test. And since we've got the Inspire out, we'll go ahead and just do this test in here. I'll hit menu. Let's see, excuse me. So I'll hit control, excuse me, and add a document. Once I escape out of that, excuse me. So control, document, and we'll just add the calculator. And we're going to hit menu, and we're going to hit statistics, and we're going to do a stat test, t-test for one sample t. We're going to pick data, and our mu is 11. Our list comes from species that I named it. Frequency 1. We are going to test it against the less than 11 and hit OK. And there's our data. So our test statistic, they have a t-value of negative 11.34, which makes our p-value 2.5 times 10 to the negative 7th, which is 0.000, 6 zeros, then a 2.5. Degrees of freedom, 10. Our mean was 4.1. Standard deviation, 2.02 essentially. Number in our sample is 11. So our p-value is approximately 0. In GeoGebra it looks a little different. I'm going to get the summary stats by clicking on the summation symbol there. And we have a mean of 4.1. We have our sample standard deviation of 2.1, approximately 2.02. And so we're going to use those two along with the 11 to do this. And I've already done it. So at the top, I selected t-test for mean. I did my null hypothesis of 11. We're going to test it against less than. Now I use 4.1 and a standard deviation of 2.1, which is well, it should be 2.0. So let me change that. If we round it correctly, or just 2 would be fine. Number in our sample is 11. And you notice we get similar statistics. So our degrees of freedom are 10. Our test statistic is t-score is negative 11.4. P-value is 0. It doesn't even give you all of these. So we're ready to go ahead and write up our conclusion on this test. You would write these summary stats out on your paper and explain them. So a write-up would look something like this. Since the p-value is approximately 11 or 0, We reject our null hypothesis that species levels in saline ponds are about 11. There is evidence to suggest that there are less than 11 species per pond in a saline pond. And a little asterisk note that the data appears to be strongly skewed right, but we proceeded with the test anyway. So put in a little note about there. One thing I didn't set before the test was done was an alpha level. In this case, I wasn't really worried about the alpha level because we could see in the data and that we were going to have species levels way below 11. So an alpha level of 0.05 seemed a little silly with data that low. So I hope this helps you understand the t-score and a one sample t, and I'll see you next time.